In this course so far, we've been discussing requirements and alternative architectures. We touched on data modeling for our software-based product to structure and store necessary information. Software design is yet another vast discipline, spanning from the client ID all the way to the written code. As an industrial design engineer, you will certainly take multiple roles in this process. At the forefront, you will map the problem space together with the customers. At a later stage, you might use code to prototype early ideas yourself. And you will orchestrate the development process, connecting the product team together. The way software-based products are designed today is relatively new. Thus, your role needs to fit in this transformed development process. A couple of decades ago, the focus was on completeness. The full list of requirements with extensive documentation were written before starting the product implementation. We will see in Module 7 that agile and lean approaches, in contrast, focus on quick and iterative development cycles. Requirements and documentation were strong motivations for modeling software throughout its design. UML, for Unified Modeling Language, is still a reference today taught in computer science classes to formalize the user, structure, behavior, environment, and implementation perspectives while designing software. Altogether, these views represent a collection of 14 UML diagrams to specify software. This reflects the strong emphasis on requirements and documentation completeness from the past approach. So why are we even discussing these? Let's just skip it and move on. Well, we move away from modeling as a fixed upfront contract toward diagrams as key communication elements. We will see also in Module 7 that the core value in an agile process lies in the conversation. Thus, diagrams here can facilitate brainstorm and reflection. They help double-checking that the whole team is on the same page. There is knowledge transfer when people join and leave the team. Most importantly, they put on paper the mental model that we develop about software in our head. So let's get acquainted with a couple of these diagrams, not with the objective to be complete, nor formal, but as a tool for communication as well as methods to iterate on the design of software-based products. In software design, use case diagrams are a way to capture the usage requirements of software. It should highlight the necessary actions that the products must enable. Its description as a list in natural language is a helpful start. Similarly to database modeling, this is a way to surface requirements. Looking back at the doorbell example, a goal could be to enter the house. For this, we need someone at the door willing to enter. This could end with this person being authorized with an open door or declined access, in which case the door would remain closed. Here we have the notion of actors. The primary actors are the one triggering the use case, the visitor for instance. Then the secondary actors are the one playing other roles in the use case. For the doorbell, we have the system itself which tries to identify the visitor, to take autonomous action. And here, identifying in the demo meant that the person should look surprised. And we have the householder who can decide to interact with the visitor and open the door. Note that the householder can also be in the role of the visitor when coming back home. We mentioned triggers as the primary actors start the use case. For the doorbell, it could be the presence event, for instance, in the street. It can give us two main use cases, such as request access, and unlock the door. A step might have several ways to be completed. This is, for example, the case of the notification, when householders at home can be alerted by the doorbell ringing, or householders on the go can be notified on their phone. You can see that these elements help us get more concrete about our idea of the doorbell. You are probably already thinking that a few elements I mentioned could be argued or clarified, and this is the point. Through the use case, we create a structure to discuss, refine, and align the whole team on what should be the software-based product behavior. Here is the formal look of a use case diagram where you can recognize the actors, the use case in the ellipse, and the boundary of the system. Referring to the earlier discussion of fast and iterative processes, this diagram could very well be a whiteboard drawing like this one, for instance. The key is the explicit and clear communication in a common language without letting formalities be in the way of getting things done. Connecting to computational thinking introduced through the Python programming assignment, the main purpose here is to decompose problems into manageable parts. Small parts can be easily described, brainstormed, but also easily implemented. Some final tips about use cases. It should always start with a goal, which derives the need for the whole case, like you would do with personas or similar storytelling design methods. It is important to write use cases as narrative, using simple but ambiguous language that the whole team can understand. As you can see, this is not about the technology nor user interfaces here, but the intended flow of actions. We keep all technology and touch points out of this perspective. Your diagram should reflect reality, the actual behavior that we want to achieve. And this is more important than the actual notation that you use, as long as there is a common understanding. With the use case diagram, we specify what behaviors must take place. It is scenario based. We want to express intentions and high-level paths very close to the user's mental model of how the software-based product is expected to behave. Activity diagrams and flowcharts are two similar ways to express how the behavior is accomplished. We can distinguish the activity diagram from the flowchart, saying that the activity maps the required steps of a use case rather than the implementation details. The flowchart that we already used in the programming assignment is for problem solving, illustrating the solution which can be directly implemented into code. Once again, in reality, you want to get your point across and ensure that the whole product team is on the same page, rather than discussing whether it should be an activity diagram or a flowchart. Make sure that your intentions, however, are clear and unambiguous. Chances are that you will naturally draw these diagrams with a specific level of abstraction depending on what is to be discussed and communicated. So let's go back to the doorbell. We specified the goal to enter the house. With the flowchart, we will now take a system perspective, as we will only design the system and not the human actors. Thus, a presence event starts the flow. This would turn on the identification system, this emotion detection. The result of this process leads to a decision point with a diamond. Does the system recognize the request as from an authorized person, this surprised emotion, so we can grant the access? Yes, then let's open the door. No, then we need to check whether there is someone at home to proceed, so we can ring the bell or maybe ring on the phone. The presence detection and the recognition could be both detailed further, as there might be several ways and steps in order to detect and recognize a person. For instance, the recognition could be video-based, as we chose in the demo. Then the system needs to turn on the camera, take a picture, detect a person, and check it against a list of authorized visitors. We note that if the visitor is not automatically granted access, the flow stops. A new flow will start triggered by another event, either the householder pressing the push button to open the door, seeing on the camera that he wants to open to this person, or checking on his phone to act on the notification. As we refine the flowchart, we iteratively get closer and closer to the specific instruction, closer to the code to be implemented. This relates to the decomposition, pattern recognition, and algorithm design of computational thinking. Both flowchart and activity diagrams have a set of shapes for different types of flow elements, beyond rectangles for processes and diamonds for decisions. Regardless of these shapes, what is important is your consistency throughout the diagram as well as the abstraction level. We saw in the example that we can zoom into the process to detail further, but on a single flowchart, all elements should be on the same level of abstraction to make it an effective conversation tool. Sometimes the challenge lies more in the sequence of actions between the elements of the system rather than the logic itself. For instance, the motion sensor detecting a presence, turning on the light, turning on the camera, sending a picture, etc. The focus is on the sequence of action. In that case, you might feel more comfortable expressing the behavior of your system in a sequence diagram, which will focus on messages exchanged between participants, the elements of the systems listed in rectangle at the top. The times goes from top to bottom, and the message flows from participants to participants in a timely manner. Transitioning from a storyboard to specification diagrams is a bridge from design to computer engineering. There's a whole list of diagrams and techniques that can be used in software design for this transition. It should create a common ground without ambiguities, and that's the key, across the design and the development team. But it should also facilitate the fast iteration process of software development, as it becomes easy to precisely discuss the changes and impact of alteration on both the design and the implementation. Keywords such as abstractions and events start emerging, which will be the focus of the next video.